Okay, I'm going to do a brief recap of some things related to the unit circle. You may need to go watch my other two trig videos to get more background. But basically, a unit circle is a circle with a radius of 1 and it's centered on 0, 0. So if I draw it, this is going to be a bad circle. Basically, I've got an adjacent side and an opposite side, and the 1 is my hypotenuse and my radius. And if I know the degree angle there, like 45, I actually can figure out the A is really my x. If this is 0, 0, I can find out how far. It's going to be less than 1. And this is my y. So in this case, the cosine of 45 degrees is the adjacent over the hypotenuse, which is 1. And the sine of 45 degrees is equal to the opposite, which is the y, over the 1. And because this is 1, kind of goes away, or I can cross multiply, but it's still just x equals cosine 45 and y equals sine 45. So when I actually look those up, x is roughly 0.71. That's my warning here. And my y is also approximately 0.71. So this point up here is 0.71 high, 0.71 out and 0.71 high, which makes sense. Okay, so it's less than 1 because it can't be that far out. And so if I keep doing this for some other values, so once again, I'm going to draw a unit circle. My circle's not going to be so good. But if I go out and up, so my x is my adjacent, my y is my opposite, this is 1. And let's say this is 30 degrees. If this is 30 degrees, so once again, the cosine of 30 is x over 1. And the sine of 30 is y over 1. And when I look those numbers up, the x ends up being somewhat far out. It's about 0.87 out. And my y is not so far up. It's only 1/2. So the coordinates for that point are 0.87 and 0.5, or 1/2. Okay? And then finally, what's very interesting is if I do one more, make it a little steeper. This is supposed to be a 60-degree angle. Okay, and I'm going to draw my circle there. Once again, that's 1. My y is opposite. My x is adjacent. So when I do that, the x value, the cosine, ends up being 1/2 because it's not so far out now. And my y value ends up being, the sine of 60 ends up being the 0.87. So you'll notice those values have kind of flip-flopped, except I'm writing them wrong again. This 0.5 and 0.87. And then what's also interesting, as I go up to the top, as I go up to 90 degrees or pi over 2, of course that is 0 and 1. But as I go over here on the other side, at kind of a mirror image of 60 degrees, well, over there, these are reflections of each other. So this is still 0.5 out as far as the x value. I've only gone out half, but it's in the negative direction. But it's still 0.87 high. And these kind of reflections happen all the way through. So that's important to remember. Same thing here. If I had something out this far, if it was up 30 degrees, which actually would be an angle of 150, in the same way down here, this would be an angle of 120 because it's 30 past 90. So this is 150, poorly drawn, but basically this would be negative 0.87 and 0.5. Because it's still 0.87 out, but in the negative direction, still 0.5 high. And the same would be true down here. At 30 degrees down, which is basically 180 plus 30, or 210, at 210, it would be negative 0.87 and negative 0.5. Because it's 0.87 out, it's 0.5 down, both negative direction. So those kind of patterns are very helpful. But these numbers are kind of difficult. So we want to use easier numbers. So that's the next thing we're going to do. So I'm going to briefly show some math we did in class. When I've got a 45, 45, 90 triangle, I can do some math. I can say x squared plus x squared equals 1. This is really my y, but they're the same value because it's half a square. And then I can solve this by dividing by 2 and taking the square root. And ultimately, the correct answer here is square root of 2 over 2 is the width, and the y value is also square root of 2 over 2. It was very quick. You can freeze it and go back and look at the math. And the same thing happens down here. This should be a, not a 5, a 1/2, a 0.5. trying to use fractions here. We're trying to do exact values as opposed to 0.87, which is an approximation. 30, 60, 90 triangle, half of an equilateral, so that's 1/2. And when I go through the math, I get, and once again, my math is not so good here. This is 1/2 squared, which ends up being 1/4. And when I subtract 1/4 from both sides, it's 3/4. My materials weren't prepared ahead of time. Square root of 3/4 is square root of 3 over 2. So this side, my y value, is square root of 3 over 2. And this is, my x value is 1/2. So I'm going to go back and do those same triangles now, except I'm going to do them with these numbers. So if I flip my page here, I've kind of already done that. This is a 30, 60, 90 triangle. This side is 1/2, that's my x value, and this side is square root of 3 over 2 high. That's my 0.86 basically, or 0.87. This is a 45, 45, 90 triangle. So this is square root of 2 over 2 out, which was roughly my 0.71, and this is square root of 2 over 2 up, so that's my other 0.71. And then finally square root of 3 over 2, this is the same triangle here except flipped sideways, so it's 30, 60, 90 still, but it's 0.87 or square root of 3 over 2 wide and 1/2 high. And so that's at 30 degrees, 45 degrees, and 60 degrees, or in radians, it's pi over 6, pi over 4, pi over 3, this is pi over 2. As I get over here, it's 2 pi over 3, and this is where that pattern starts repeating. It's still 1/2 out, this is out 1/2, but on the negative side of the origin, and it's still square root of 3 over 2 high. So short leg is 1/2, high leg, long leg is square root of 3 over 2. Same thing here. At this is 3 pi over 4, or 135 degrees. So that's going to be negative square root of 2 over 2 wide, but square root of 2 over 2 high. And then finally, I can keep going. This is 5 pi over 6, and this is only 1/2 high, but it's square root of 3 over 2, or about 0.87 out in the left direction. And then I can keep going around. Okay, so this is pi, of course, which is at, we're at -1, 0. And down here, all the numbers are going to be the same. When I reflect it down here, same numbers, just in this quadrant. So this ends up being a negative square root of 3 over 2 wide, x to there, and then negative 1/2 down. And that right there is 7 pi over 6. These you should learn. I'm not going to finish it for you. And so the last thing I want to show you is there are some values here that we can kind of double check. There are different ways to express these, and it's worth knowing what they are. So the question is, if I ask you the cosine of 60, what is it? So you can look it up. So cosine of 60. Cosine, once again, is the x value. So cosine is x. It's alphabetical order. And sine is the y value. Things are getting squeezed in there. Okay? So the cosine is 60. This was my 60-degree angle. Cosine is x, so cosine of 60 is 1/2. But there's some other values around that are also 1/2. Like, what's another value that's 1/2? Well, that value right there is 1/2. So cosine of 60 is equal to 1/2, but it is also equal to the sine of 30. So there's a lot of duplicate values in here in different ways to express them. Sorry, you can't see that. Cosine of 60 is 1/2 because it's right there on my triangle. It's the x value is the cosine. But 1/2 is also, this is my 30-degree triangle. That is the sine of that. Similarly, I can do this with radian degrees. So if I say negative pi over 4, okay? So I go out here, negative pi over 4 is down here. This is negative pi over 4. And I don't have it filled in yet, but I can figure it out without even filling it in. I'm like, oh, it's a reflection of that. So I'm looking for sine, which is the y value, but it's down in this quadrant, so it's that number but negative. So the negative, that's going to be negative square root of 2 over 2, because I know it's the y value there, but it's down here, so it's negative. And then there are other values of that. This is sine of negative pi over 4, but there are other square roots of 2, or negative square roots of 2. In fact, another way that I could write that is I could say, oh, that's the same as negative sine of pi over 4. Those are equivalent, because pi over 4, sine of pi over 4 is square root 2 over 2, but I put a negative out front. So that's actually square root 2 over 2, negative square root 2 over 2. Lots of different ways to express these because we're kind of using the same numbers all over again. I'm going to do 2 more quick examples. Sine of pi over 2. That right there is pi over 2 is up there. Sine is 1, so that's equal to 1. And there are some other values around the circle that are also equal to 1, or negative 1, and then I could take the opposite value. Last one, cosine of 180. So cosine of 180 is the x value over here, so that's a negative 1. So if you look at these two, I can say, oh, the sine of pi over 2 is equal to the opposite of cosine of 180. There's just lots of different ways I can equate these things just because I'm repeating the same numbers over and over again. And this is just a way that we can get familiar with our radian measures compared to our angles. And then there's really only 0, 1, 1/2, square root of 2 over 2, and square root 3 over 2. Those are the only values I'm using for this simple unit circle. I think that's plenty. Ciao.